Coming across to Srijan Pal Singh, who's here with us in the studio. I see you're having a model to explain this. You can go ahead with your explanation because even the Group Captain Jha was quite articulate. Tell us about, first explain what you want to explain and also the significance of it, that why do we need to study the sun?
Correct. So Group Captain Jha has already explained to you the parts. Let me just point out where each part is and just go a little bit detail on that. See, what's important is for us to study the sun from the perspective of the X-ray spectrum. And why is X-ray spectrum so important? Because if you're sitting on Earth, on ground, Earth is covered with a magnetic cover. We all know that. The Earth has a magnetic field around it, which means X-ray cannot be studied sitting on the surface of this planet. You have to go in space to actually analyze the X-ray from the sun. And sun talks a lot, gives a lot of messages on X-rays. A lot of solar flares, coronal mass ejections. I'll tell you why it's important later, but let's come to this model first. Now, this is the simplified model of Aditya-L1. These are solar panels, very easily visible. These are solar panels. This is where the energy comes from. This is what Group Captain Jha was talking about, the suite. Now, the suite will study basically the ultraviolet spectrum. Our sun is also in ultraviolet, X-ray, and visible light. Visible light is studied by this part. This is called the VELC. This part is what will study the solar winds. Solar winds are very intense. Huge, high intensity, high velocity, and very heated winds are blowing across the surface of the sun. These can cause significant impact on our planet. Now, we talked about the sun also is a magnetic field. So this is the magnetic radiation, and this analyzes the magnetic fields which the sun is creating. This part will actually come out. So it will be a long, like an antenna. This is PAPA, what Group Captain Jha was talking about. This study has nothing to do with PAPA. It is acronym for plasma analysis. So this is a plasma analyzer. These two parts, little dots here and this one here, will study the X-ray spectrum. They look tiny, but they're actually the most important component of this. And of course, here's the motor. The motor, which is the engine, is called the LAM. And what it does is that it generates enough approximately equal power to a motorcycle, but it will keep this Aditya-L1 in the orbit of L1. So the L1 orbit is quite big. It's not a point. Lagrange point is not a point, as Group Captain Jha said. It has to go around, and it's a very wide orbit it has to do. It is also an unstable orbit, which means that if you do not have this motor and doesn't work well, then Aditya-L1 can be lost. It happened in 1990s when SOHO, it's an ESA solar analyzer, it got lost because they were unable to maneuver it. So it's just that we are reaching the point does not mean it's the end of it. We have still complex things to do ahead in the next 5 years. We have to keep it in the orbit and keep analyzing things. Now, why do we need to study the sun? That's very important. Why are we so interested about it? Sun is the source of life, light, and heat on our planet. Sun is also the source of X-rays, of radiations, and of very harmful particles which Earth is able to stop, but we need to keep a track of it. 2 or 3 things are extremely important. One is solar flare. Solar flare are high intensity ejections which happen from the sun. The electromagnetic radiations traveling at the speed of light, which can hit the Earth. So it's like, imagine a large amount of radiation, highly heated, high energy, and it's beamed all across the sun. It keeps happening. One of them can hit the Earth. It does happen quite often, and whenever it does happen, it can disrupt electromagnetic signals, which means our devices, our electronic devices, can be affected by it. But that is actually the smaller problem. The bigger problem is called the CME, which is the coronal mass ejection. Coronal mass ejection is when a large amount of plasma and ions get accumulated in the sun, and they're shot off like bullets from the sun's surface all across in space. They travel not at the speed of light. They actually travel much slower than the speed of light. It takes about 12 to 18 hours for a coronal mass ejection to hit Earth, if it does lie in the path. But if the Earth is hit by a coronal mass ejection, massive events can happen. And we have seen in mid-1800s, the biggest coronal mass ejection hit Earth, and it is called the Carrington event, in which in New York, we had telegraph wires. They all caught fire because of the fact that the sun's coronal mass ejection had hit Earth. A smaller ejection had hit Earth in Canada in 1990s, where power was lost for about 12 hours. And one of the coronal mass ejection actually hit 10 years ago, when we also lost some satellites. Billions of dollars of satellite, of electromagnetic devices, and safety of humans depends on analyzing coronal mass ejection. And that is why we need to study the sun. because we need to keep a track of how the sun operates. I told you coronal mass ejection will take about 12 to 18 hours to hit Earth, which means an early warning detection system has to be established in the event a CME or a coronal mass ejection is about to hit Earth. So all those things make sun a very viable candidate to study. We also know that the sun, the surface of the sun is called photosphere. It's about 4,000 centigrade. Above it is its atmosphere, which is called the chromosphere. Photosphere, chromosphere, which is about 8,000 centigrade, and above it is the corona, the outer component of the sun. That is about 1.5 million degrees centigrade, and we do not know why is it so hot. So we need to also analyze that, and that's what Aditya-L1 is going to do. Aditya-L1 is in L1 orbit, the L1 Lagrange point 1 orbit. Remember that there are 4 or 5 other such solar analyzers from ESA and NASA which are there. So there's some traffic there, and we have to keep a close track on how we keep maneuvering it for the next 5 years at least, and keep getting these beautiful pictures of sun from visible, X-ray, electromagnetic rays, the plasma analyzer, and and also the ultraviolet, the range in which we'll click photographs. So look forward to that. I think all the best to ISRO and all the scientists there. It's a fantastic job that we are the third agency which is analyzing the sun. It will not just be for India where it is useful, but also for the rest of the scientific community across the world.